Hi, and welcome to IGCSE and GCE Maths Prep tutorial. Today we are going to be discussing on sequences, what is the meaning of sequence, types of sequence, and how to identify the different types of sequence. Now I've left little notes on each of it. So you can see sequence is a list of numbers or shapes which follow a particular rule. Each number or shape in the sequence is called a term. Under sequence, we have different types of sequence. We have the Fibonacci sequence, geometric sequence, triangular sequence, arithmetic sequence, square, and cube. We'll be going deep into just a few. The geometric sequence is a sequence also known as geometric progression, are the ones where consecutive terms are found by multiplying the same value each time. This is known as the common ratio. Now we go to the next slide. Geometric sequence. Geometric sequence, also known as geometric progression, are the ones where consecutive terms are found by multiplying by the same value each time. This is known as the common ratio. You can see from the example, you can see 2, 8, 32, and 128. Now the difference between these numbers is multiplying by 4. You multiply the previous number by 4 to get the next number. Now you can see here, the first number is 2. When you multiply 2 by 4, you get 8. When you multiply 8 by 4, you get 32. When you multiply 32 by 4, you get 128. So that's the thing with geometric sequence. There's always a common ratio between the numbers. Now we move to the next one, arithmetic sequence. Arithmetic sequence, also known as linear sequences, are arithmetic progression or arithmetic progressions. Are progressions where the terms increase or decrease by the same value each time. This is called the common difference. As you can see, the numbers are increasing by the same value each time. You can see 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14, 14 plus 4 is 18. So if you see this, you know that it's an arithmetic sequence, and you see the geometric sequence is increased by multiplying the common ratio, to the previous number to get the next number. While the arithmetic sequence increases by the same value or decreases by the same value, you either add or you subtract to get the next value. Now we'll look at the Fibonacci sequence. The rule in Fibonacci sequence is always add together the two previous terms. As you can see, the 3 plus 3 will give you 6. Then 3 plus 6, which is here, will give you 9. 6 plus 9 will give you 15. 15 plus 9 will give you this. Now, the quadratic sequence. In quadratic sequence, the difference between terms changes by the same amount. Now, you can see here, 2 plus 1, you have 3. 3 plus 2, you have 5. 5 plus 3, you have 8. 8 plus 3, you have 12. 12 plus 5, you have 17. 17 plus 6, you have 32. It's increasing. The difference, the common difference in between is increasing by 1. You keep adding 1 to the difference, keep adding 1 to the difference, and you keep going from the previous to the next one. We're done with the introduction. Now we're going to our examples. Our example 1 is find the next 4 terms in the sequence. We have 5, 6, 8, and 11. So how do you identify the difference between each number? Now you look at number 5 and number 6. Let me draw my loop first. There. Then we'll have one from there to there. Then we'll have another one from 8 to 11. Now I can see that the difference between 5 and 6 is 1. So I think the difference between that should be plus 1. Plus 1. The difference between 6 and 8 is 2. So we should have plus 2. The difference between 8 and 11 is plus 3. As you can see, you see there's a pattern there now. It's increasing by 1. The difference is increasing by 1. Yeah. So that's it. That's the difference between 5 and 6 is 1. The difference between 6 and 8 is plus 2. And the difference between 8 and 11 is 3. So now it's saying find the next 3 terms. So how do we get the next 3 terms? We've seen from the previous one that 5, 6, 8, and 11, the difference was increasing. The common difference was increasing by 1. The difference here is 1. The difference here is 2. The difference here is 3. So how are we going to get, let's try and get the next 3 terms. Now the next 3 terms, if you see this 11 plus 3, obviously we know the next one is going to be plus 4 if you follow the pattern. So we have, if you have 11, if you have 11, to get the next number is going to be plus 4. 11 plus 4 is going to be 15. So we have our 15. We do our loop so that we don't get confused. Plus 4. Now the next number is going to be, if you have, this is 4, obviously the next one is going to be plus 5. So if you have 15 plus 5, that's 20. So we have our 20. We put in our loop. Then we have our plus 5. So we say the next 3 numbers. So we're left with one more number. If this is 5, the next one is going to be increased by 6 plus 6. So 20 plus 6 is 26. We put in our loop to explain to a layman what we're doing. Plus 6. And that's it. We're done with this question. So you see, it's as easy as anything. Now, if you notice, we have to still identify what kind of loop this is. From the explanations I gave before, it's obvious. This is a quadratic sequence because the quadratic sequence, it increases by 1 each time. It increases by 1 each time. Okay, so I've just indicated there that is a quadratic equation. I left a little note. This is a quadratic equation because the difference in between the numbers is increasing by 1 each time. So I think we're done with this question. We'll move to the next question. Okay, example 2 says the first 3 terms of a quadratic sequence are 5 plus x, and 7 plus 2x. Find a factorized expression in terms of x for the 6th term in the sequence. Now, we have it arranged. I've arranged it properly. We always need to draw our loop so that we don't get confused. The loop from 5 to 5x, and then another loop from 5 plus x to 7 plus 2x. Now the difference between 5 and 5x is plus x. Plus x. And the difference between 5 plus x and 7 plus 2x is 2 plus x. If you add 2 plus x to 5 plus x, you would have 7 plus 2x. So the difference is 2 plus x. Now the question says we should find the factorized expression in the terms of x for the 6th term in the sequence, which means we have to find our 4th term, 5th term, and then 6th term. This is our first term, second, third, now we're going to look for the 4th term. So let me just draw the loop just in case here. So we're going to look for the 4th term, which is supposed to be here. Now, we can see, it already says it's a quadratic equation, so we know it's either increasing or decreasing. But from what you can see here, it's increasing. If you look at the first number, 5, and the difference is plus x, and then the second one, the difference is 2 plus x. So it's obvious from this, we can see the pattern. The common difference is, we're going to be adding 2 to the common difference, because if you look at this, difference between this and this is 2. So I think all for the 4th term and 5th term and 6th term, we're going to keep adding 2 to the common difference. So let's look for the 4th term. Now, for here, the difference we're going to be having here is going to be in bracket 2 plus x close bracket plus 2. So now when you add this up, you should have 4 plus x. So now this difference, we're going to add it up to what we have here, our 7 plus 2x, to get our 4th term. So how do we do that? We have our 7 plus 2x then plus bracket 4 plus 2. When you expand this, you should be having 7 plus 2 x plus 4 plus x after you've expanded it. Yeah? Now, you have 7 plus 4 is 11 plus 2x plus x is equal to 3x. 3x. So this is our 4th term. I'm going to put it right here. 11 plus 3x. So we are going to do the same thing. This is our fourth term. We're going to do the same thing to get our fifth term and sixth term. So because of time, I'll just put it in there. I've solved it already, so the I'll just put in the fifth term and the sixth term. This is the sixth term. This is the common difference. This is the common difference. And this is our final answer. Over here, final answer is 5 bracket 5 plus x close bracket. We've come to the end of this tutorial. We'll have a part 2 coming up next week, where we'll talk about we'll go deep into the sequence. I'm going to teach you how to using the end stem and then more practical questions for you to understand the topic properly. I hope you enjoyed my class. Thanks for watching. Hope to see you next time. Bye bye.